at Distributech 2023, one of the sponsors of these interviews, and these are interviews with thought leaders from around North America and the globe. Our sponsors are H2 Scan. H2 Scan is the leading sensor manufacturer for hydrogen sensing in a lot of different applications, in transformers, in battery room safety, in processes and safety, in industrial, and in the future hydrogen economy. So I want to thank our sponsors, and I want to thank all of our guests, and I hope you enjoy this interview. And my first guest is Pierre Girard. He is the president of Hexacode Solutions. They are a software company here at Distributech, I think for the first time, right, Jean-Pierre?
First time.
All right, congratulations. Thank you for being here.
Thank you.
We enjoyed it. So first of all, tell me a little bit about your background in the power industry and why you got into the power industry whenever you did.
Okay, so I'm an electrical engineer by trade, and I spent most of my career in the power industry, mostly with Siemens. Okay. But what brought me there, I think it's the region where I come from, because I come from Saguenay, and there was an impressive plant from, let's say, Alcan at the time, and which became Rio Tinto. And as a kid, there were dams and so on. So that was the, I think that was the trigger for my career in electrical engineering.
Did you play along the dams, and now you decided to go to work for the company?
I mean, it was not kind of possible in Saguenay to play around the dams. I can tell you that. So, but it's just probably what impressed me the most.
Okay, that is the strangest story about why somebody came into the power industry. So. And you're in Montreal, company headquartered in Montreal?
Exactly, we're based in Montreal, and the story is that coming from Montreal, obviously, but most of my career has been in Montreal.
Okay. So you're here at Distributech, and you're in, is it the Innovation Center stage here? What is it called?
It's called the Initiate.
Initiate,
exactly.
Right.
So we're a bunch of startups, and it's great because contrary to, for example, Sigrid in Paris, now there is a competition, and there is just great technologies around Hexacode, like guys with EV chargers, name it.
Yeah. Are you coming to the IEEE Grid Edge in April, which is also, I think they also have like a startup area.
This is not yet decided.
Okay, all right. So when we were talking beforehand, and you mentioned that, you kind of talked a little bit about the company and what the company does. We're going to get into a lot of that, but you've been in the power industry a long time. You do, and working with Siemens, you've got to have seen a lot of different things. But just step back for a minute, and as the president, and now you're looking at the problem. What is the problem that you're trying to solve that the industry has? Now, I also have to say, you just mentioned that you were a startup, and then COVID hit, so you were kind of stuck in a rat.
Yeah, exactly. So I will start with the solution that we bring to the industry, and then we'll talk about what happened. But mostly, I think what is happening, or the problem we want to solve, is extending the life of assets. Okay. So, which means that it's giving options to the utilities and to make selection of assets that you will be then able to prolong the life a bit, to give you options, because presently the supply chain for power transformer is not something that is solved. And with the high demand of energy, right there, okay, you have a problem. And aging infrastructure brings another dimension. So for us, I think what makes us different is the fact that not only do we give the condition and predict the condition of electrical equipment at the asset level, but we give also scores and result at the component level. So that's what we bring, and it makes it easier for people to decide whether they upgrade and extend the life or not.
Okay, so before we get to that, because I'm going to come back to that, I want to get to the COVID shutdown. You had 2 years of isolation where you're ready to come to market. Okay.
That was crazy, because we were qualified for the first time. I think Sigrid in Paris had the startup kind of hub, exactly like what we have here. And in 2020, we were selected, we were going to Paris, and then suddenly COVID hit. It was canceled, and then it's every 2 years. And for 2 years, like, it's pretty tough if you're a startup in the utility business to get the attention when you cannot even travel, you cannot meet people in person. So for us, we just said, okay, fine, okay, I'm going to still do some stuff on business development, but we just kept developing the software. So you never lose time, but it's simply that it's burning your cash. That's what's happening. So
no one likes to burn their cash, you know?
not exactly.
So we've kind of gone into it. One of the big problems last year when we were at IEEE PES and when we were, we had staff at Sigrid Paris, was we kept hearing over and over supply chain issues. That was one of them. Aging infrastructure was another one, particularly transformers. Transformers is a love of mine, the heart of the system, and it's a love of mine.
Yes.
So you've got this this industry very slow to change. Okay, the utility industry is not like jumping onto the new thing. They want you to be new but proven. Okay, bring new but proven.
Yeah.
And so you've got this industry that's reluctant to change, and suddenly now we're struggling with the same thing, supply chain issues. We're even more aging infrastructure, but now we have demand curve problems.
Yep.
So you got a demand for transformers, demand for everything, just like a hockey stick. You know, it's
Or a
starting,
perfect storm.
perfect storm, and all of that's coming together now. So the good news for you is we see a lot of utilities much more open to change more quickly.
Yeah.
And they're looking for solutions to exactly what you said. So you kind of mentioned it, but it strikes me as interesting that you've got a solution without it being a machine or a component that can extend the life of assets through software.
Yeah.
Tell me about that. How does it work?
Okay, it's in a sense, okay, first of all, what brought me to this company is an IEEE paper. Okay, so probably I was having a hard time sleeping, but I read an article on.
I've written one, so I might.
Yeah. So I read an article on how to evaluate the health of a power transformer. Okay, it was a paper from Kinectrix at the time, and I simply said, okay, at the time. The real time was not there. It was not really component based, although they were looking at each component. What I liked about that paper is that if you need to evaluate an asset, you have to go down to the components and the way they degrade. Right. So what I had in mind was simply to say, we are doing the test, but we don't bring the information at the level of component, we bring it at overall, let's say, results. And the other problem with the health index or asset condition is that you could have a score of 80 on a power transformer. It's normally a weighted average. And if you have an issue like oil leak on the bushing, okay, it won't show on the result of the health index or so we said, okay, let's combine few things. First of all, let's have the condition done overall. Let's do the condition by a bushing for me is like an asset. So I'm going to give it, it's the same test, but I'm going to give it an interpretation, bushing number one and so on. So the image that you have the overall, you have each component, like if it would be the most important thing on Earth, and then we have all the templates and all the checklists pertaining to a specific model of bushing, specific model of tap changer, and the other thing that we have is the calculation that goes with it. So we treat the asset like it's a combination of components.
Right. Where did you get all that data? Because that's data-centric, data-rich.
The relationship with, for example, Kinectrix was the interpretation of tests is not my trade. Like, although I'm an electrical engineer, when you open up, let's say, the science of power transformer, you become humble. Okay, that's the first thing. So I know that I don't know. So that applied to a power transformer. I needed experts. So these guys help us. But if you look at the industry, you go to Sigrid, IEEE papers, it's well documented, it's well explained. So what we offered is a software, and the challenge for us was to make it scalable, because we have to deal with a lot of assets, and make it so that it's real time. So the timestamp on our system is 1 millisecond. So, and be able, okay, to dissect the asset and apply complex let's say, interpretation. So what we have is, if you have dissolved gas, for example, those tables of dissolved gas are embedded in the system. So it's kind of an expert system. And to go a bit further, like if you take the fact that we have less and less people available on people in the trade available. So the expert system helps because making decision, you don't need to rely on necessarily expert because they're embedded in the software. So it's easy for somebody to see that we have an issue with bushing, that bushing in particular. And then you call maybe the expert to say, okay, how do we go about it? But you know that this is where you have a problem with the asset. And the last point, but not least, is that we haven't done it just for transformer. We do it for breakers, wood pole, and when you look at large utilities, they deal with millions of assets.
Right.
And the capacity of the platform is to have in one server 25 million objects. And the reason for that is that the CTO, our CTO, is a former R&D guy from Ericsson Communication. When I gave him the challenge, he said, okay, do you want how many millions? Okay, timestamp, millisecond, are you sure it's enough? Or I could give you more. Yeah. So he took that, let's say, challenge and made it happen. So that's what makes us unique. And the last thing is that we have an historian. That the database is based on an historian, specialized historian. I'm not competing with the others. So I could go back in time. I could give you statistic of a network, for example.
Okay. Are you in beta anywhere? Have you sold the software to somebody? Are you in beta anywhere?
It's funny. Like the first, like I'm electrical engineer, but at the time at Siemens, I was responsible for the relationship with SNC-Lavalin, and they built in Montreal a mega hospital. So the software was born in an hospital. So that's my
a maternity ward,
yeah,
right?
Yeah, for sure. Yeah, not the emergency room. So and that was great because it brought me to the digital twin, and I'm going to explain that. Like the challenge was to make a digital replica of the hospital. Right. This hospital it's a $1.3 billion hospital, 12,500 rooms. 200,000 walls, 25,000 electrical outlet, and they said
you seem to know that a lot about the hospital.
I mean, yeah. I haven't visited it too often, but yeah, this is the challenge. Like they wanted us to tell, to have in the software about 60 fields describing a room, and whether there is, let's say, medical equipment, electrical outlet, and so on. So it's kind of a digital replica. And what we did is we took the 3D design from Autodesk, extracted data, and then we went into the inventory. And that allowed SNC, because it was part of the contract, to have this digital replica. And at the end of the project, they even asked us, what are the difference between the design and construction drawings and a year later, what were the changes that were asked during that thing in order to make let's call it a claim. Yeah. And they used the platform because we could make the difference between what was originally as a description of the room in Revit and what it was during so we had an extraction that made it easier for them to do this. So the payback was quite fast on this implementation, I can tell you.
Oh, and there's cybersecurity issues with medical, right? There's cybersecurity issues with us. So I want to have you go up to 35,000 feet. You're on an airplane with me, and I'm asking you as an expert in the industry, what are the future problems that you think the industry is going to face that Hexacode is going to solve?
Again, I'm back to extending the life. Like, we're talking about sustainability.
Right.
Okay, more and more and more. And one way to help Mother Earth is to demand a bit less. And the way to demand a bit less is to extend the life. So if I take my life, I probably have ordered 15 cars. Okay? Right. And if I could make it, and if the cars would have been maybe better, or my strategy better, maybe I could do it with 5 cars in a life. So 5 cars in a life, multiply it by the number of people and that's the kind of solution. So the amount of energy that is needed to build a transformer, if we would calculate that, and if you could save, let's say 5 years, okay, to the demand, because presently, if I'm Siemens, Hitachi, all these companies, the order entry is gigantic.
Right.
So they don't have a problem with this. But for the planet, if we want to do something, and it's valid for any kind of infrastructure, and that's the beauty of the platform, is that we started in an hospital, and this start exposed me to BIM, Building Information Modeling.
Right.
And presently, I've been invited by a utility in Canada to do a presentation on digital twin applied to grids.
Yeah.
And I did the same in Paris. And what it means is that when you do design and construction of a station, a power station, today, all the utilities are, all the consulting firm working on it are using BIM.
Right.
Okay?
Right.
So what we're doing is we just take information from that design and construction, we do the commissioning, and then we operate and we follow the equipment for the entire life cycle. So that's what we're good at.
Yeah.
And that has been even recognized by UK Research and Innovation, because we are very strong on the operational side, and they are in the industry, construction and design, very strong on what I consider very complex stuff.
You should get involved. I imagine you are, but smart buildings. You know, IEEE has smart cities, smart grid, and now down to smart buildings. And a lot of that is exactly that: is knowing the assets and making them, number one, energy efficient, and number two, having them last longer before things wear out. But that's really good to hear on transformers. I know the transformer manufacturers would normally say no, they want it with the backlog order system now that is making customers unhappy. I think they want to serve customers better, so getting the existing infrastructure to last longer would go a long way to this hockey stick demand curve.
Absolutely.
You know, and we're going to desperately need it. There's a new chip manufacturing company coming into Arizona from Taiwan. They need $300 million worth of transformers, and they're having a hard time finding them because they want to open on a certain date, a rush to get chips made in the United States, right? However, they can't get power transformers. They can build the building, they can put the wiring in, they can put the machines in that build the chips, but they can't get the power to the machines. It's a fascinating problem that we've got. Okay, our guest has been Jean-Pierre Girard. Thank you so much. I'm glad you're here, and I wish you much success and luck in this industry.
Okay, thank you very much.
This has been an APC Technologies production, and we thank you for joining us. Our sponsors have been H2 Scan and Distributech, and of course, the communities of APC Technologies, which is Transform Technology, Power Systems Technology, Green Energy Technology, and Women in Power Systems. So thank you.